So to pick up where we left off, in the first example, the legs were both 3 and the hypotenuse was 3 times the square root of 2. So my question is, I wonder if that relationship between the legs and hypotenuse exists all of the time. So let's derive the 45-45-90 relationship, and we're going to see that this derivation comes from a square. So to make our derivation easy, let's assume that all sides are 1 unit long. Can't get easier than that. And because we have a square, we know that we have 4 right angles. What I'm going to do is I'm going to draw a diagonal, and we know that diagonals in a square bisect opposite angles. And so what that does is it leaves me with a 45, 90 triangle. And what we can do is find the hypotenuse of this 90 triangle by using the Pythagorean theorem, right? We know that a squared plus b squared equals c squared. We know that 1 squared plus 1 squared equals c squared. So this would be 2 equals c squared. C is equal to the square root of 2. So again, this is interesting, right? The hypotenuse is essentially 1 times the square root of 2. So it seems like this is happening again. In a 45-45-90 triangle, the hypotenuse seems to always be the square root of 2 times the leg, which brings us to the following conclusion. If we completed this type of calculation for any 45-45-90 triangle, because they would all be similar, we would have that same relationship. So this can lead us to conclude that in any 45-45-90 triangle, whatever the legs are, right, if we call them x, the hypotenuse is always going to be x times the square root of 2. The sides are always going to be in this exact same ratio. So in our next video, we're going to use this relationship to find the missing sides on a 45-45-90 triangle.